Hello everyone, we are Team 13 and we are presenting two companies today. First one is called CoreWeave. It is a specialized cloud provider that is based in New Jersey, USA. It provides massive scale GPU computing. The demand for such services comes from activities that require immense amounts of computational power, such as AI, VFX, rendering, and scientific computing. The business model is viable since buying up top-level GPUs, mostly NVIDIA's, are an expensive capital expenditure, and new GPUs keep coming out. Companies wouldn't want to spend so much for a model that is going to be outdated, and they have to buy it again in a couple months or years. The most impactful product is a GPU-assisted platform. Its core technology involves providing bare metal and virtual access to a massive fleet of latest NVIDIA GPUs, interconnected with high-speed, low-latency networking. The specialized focus on GPU-centric workloads distinguishes it from the general-purpose cloud providers. CoreWeave's target market consists of AI and machine learning developers, ranging from the large ones such as OpenAI, Meta, Microsoft, and smaller B-Post-Tech. CoreWeave faces competition for two main fronts. The first is established major public providers such as AWS, GCP, or Microsoft Azure, which are all expanding their GPU offerings. The second is a growing field of specialized GPU providers such as Lambda Labs or Paperspace, which, like CoreWeave, focus on providing high-performance computing AI and machine learning workloads. Next is differentiating from rivals. Despite the mentioned competition, CoreWeave has differentiated itself through its scale, performance-optimized infrastructure, and strong industry partnerships. First one, it operates a fleet of over 25,000 high-end NVIDIA's GPUs, which are the top level, expanding its data center capacity from 420 megawatts to 2 gigawatts to meet the massive demand. This raw and scalable power allows it to secure and fulfill massive contracts, such as the multi-billion-dollar agreements that we've discussed before. Secondly, the company specializes on bare metal servers and AI-optimized server stacks, which delivers AI task processing 30 times faster and a fifth of the cost of its major competitors. This economic advantage is what gives them the edge. Lastly, it is CoreWeave's strong industry partnerships. NVIDIA, being a strategic investor and supplier, ensures CoreWeave's priority access to the latest GPUs like the Blackwell architecture. In a powerful endorsement, NVIDIA is all committed to $6.3 billion purchase from CoreWeave. Microsoft, another major partner, accounted for 62% of the revenue in 2024, and it holds a landmark $919 billion 5-year contract with OpenAI. These partnerships educate its technology, and they also validate how this ecosystem works. They also provide a long-term predictable revenue. Next. So far, we have discussed about CoreWeave's impact on digital native companies, but the value of the specialized computing power extends far beyond that. Now, allow me to present you the case of generative biomedicines. Traditional drug discovery is an incredibly difficult process. We're talking about timelines that often exceed a decade and costs that run into billions of dollars for a single successful drug. This is what generative biomedicines changed the game with a revolutionary approach called generative biology, powered by CoreWeave's compute platforms. Instead of searching for a key, they employed AI to design a perfect key from scratch. They're training enormous AI models to understand the mechanisms behind genomics and allowing AI to take over an efficient manual process of trial and error. The platform can now generate entirely new, custom-designed medicines for specific diseases. However, initially encountered a major problem, since the innovative approach required an astronomical amount of computational power. CoreWeave saved the day by powering them, as their entire platform is built by CoreWeave's specialized GPU cloud, giving them the supercomputing capabilities that is necessary to bring this method, which only existed before in science fiction, into reality. Generative was able to take the first AI-designed drug from a concept on a computer to clinical trials in just 17 months, as compared to the industry average of a decade or more. This speed fundamentally changes the model of medicine development. This case study clearly demonstrates that CoreWeave is just an AI provider, but also a fundamental enabler of scientific breakthroughs, providing the essential infrastructure that companies like generative biomedicines need to redefine the future of medicine. And now I pass on to the next part.
For the second part of the project, we are researching a company in the transport sector. The company is called Union Pacific Corporation, or UNP. It is one of North America's largest railroad companies, operating a network of over 32,000 route miles across 23 states in the US. Union Pacific's digital strategy focus can be concluded into three pillars: safety, service, and operational excellence. For the strategy that focuses on safety, the core is a shift from a reactive incident-based safety model to a proactive data-driven and predictive ecosystem. The investment leverages IoT, AI, and continuous monitoring through a vast sensor network of over 7,000 detectors, generating 16 million data points daily. This also allows them to monitor equipment health, allowing them to prevent future failures. Aside from sensors, UMP has also invested in an automated positive train control, or PTC system, that covers 17,000 route miles, that is powered by sensors, wireless communications, and onboard computers. These prevent accidents such as derailments and unauthorized movements. Lastly, UMP also leverages machine learning algorithms to analyze data collected by the sensors, further preventing possible accidents. Having said this, these are the following results: 26% decline in derailments, down 25% in unexpected breakdowns. All of these directly translate into lower costs, hence increasing the company's profitability. Future plans will continue to focus on safety and infrastructural renewal. While for the strategy on service, it involves integrating created data and using it to improve supply chain stability. The core mechanism of this investment is through the employment of APIs. This works by providing customers with programmatic booking and real-time data retrieval via a suite of 65 APIs, as well as GPS installed on 90% of the container fleets. Such technology offers proactive visibility, all encompassed within a mobile app named UPGo or ERP systems. Since the deployment of UPGo, delivery speed has increased by 65%. Gate exception has also gone down by 45%. These further drop down operational costs. Future plans will focus on expanding its API ecosystem, advancing real-time visibility through industry-wide collaboration on GPS and sensor technology. Lastly, for the strategy on operational excellence, it leverages data as a core asset to enable proactive decision-making across matters concerning their entire rail network. For example, the company recently initiated a project that combines AI and a Union Pacific build platform to generate optimal transportation plans, minimizing car layovers and allowing the company to react to disruptions efficiently. Additionally, a real-time two-way data feedback loop is under development, helping the internal logistics system, Net Control, to update the newest data. Another example is the integrated transportation planning tool, which is an AI-driven system that helps optimize the network resources to accelerate customer delivery times. These efforts has led to notable results. Average freight car velocity has increased by 6%, and car terminal dwell time has reduced by 4%. This is translated to a 64% operating ratio, which measures operating expenses as a percentage of revenue, a key indicator of profitability. UMP's long-term plan is to further embed digital intelligence into all aspects of operations. The company aims to combine human expertise and algorithmic assistance with the goal of ensuring innovations and technology works in real-world operations. Then here comes our recommendations. A core problem lies within UMP's internal employee communication system. Time is wasted through inefficient traditional methods such as phone calls, paper files, etc. The solution for this, we recommend using apps like Crew Connect or any ERP that is designed to solve inefficiency by providing real-time instructions. This can potentially save 15% administrative working time based on our guesstimate. Next, one of UMP's biggest competitors, CNI, recently invested in technology improving this transportation time. To UMP, this imposes a threat to their market share. To counter this, UMP could consider automating the whole container loading process, such as using intelligent cranes, employing robots in the transfer station, etc. Such automation could potentially save 10% loading time per train. And that's pretty much all for our presentation.